Skill 10, Reasoning in Algebra and Geometry. Example 1, all we have to do is justify the steps when we're solving an equation. So this is very similar to proofs that we did last year. For question A, what is the value of x in the picture? And justify each step, which means do a step and then say why it's true. So you might have to look back at your old notes to find why things are true. Okay, so if we look at the picture, we have a straight angle or a straight line and then a ray that cuts it off somewhere. So this makes two angles that when we add them together, you should get 180 degrees. Now, we can make this assumption by saying angle AOM and angle MOC are supplementary by the linear pair postulate. The next part is we have to know what we do with them. So if we just add those two angles together, because of the linear pair postulate, we know that they equal 180 degrees. So we say angle AOM plus angle MOC equals 180 by definition of supplementary. Well, now we know that we have a couple parts here and here for the different angles. We actually have angle measures for those angles, so we can just put those right in. So next we write 2x plus 30 plus x equals 180, and this is by substitution, the algebra property of substitution. So now we're just going to solve one step at a time. So we can start by combining our like terms, giving us 3x plus 30 equals 180, and again, this is just simplification of algebra. So now we have to get the 30 away because we're solving for x. So we have 3x equals 150 by algebra, which is just the subtraction property of algebra. And finally, we need to divide by 3 to solve for the x. So when we divide by the 3, we get x equals 50, and this is by algebra. And what did we do? We divided, so we would say division. And that is our algebraic proof of this example. So then we would just say QED, we are done. We solved it. In this next example, we're going to do the same thing, except we are looking at the picture and it's not a straight angle, so we don't know it is 180 degrees. But we are given a bit of extra information here. We are given that AB bisects RAN. So what we should remember from before is if they are bisecting, that means this is the same as this angle. So RAB is congruent to BAN. So that's where we're actually going to start. So we're going to start by saying ray AB bisects angle RAN by our given, and then the next step is angle RAB is congruent to angle BAN, and that is by our definition of angle bisector. It says that they are congruent. Okay, so now we can actually start solving things. If these two things are congruent, then that means that their angle measures are equal. So we can say one more step here. We can say that the measure of RAB is equal to the measure of BAN by the definition of congruent angles. So at this step, we can do our algebra because we have the angle measures. So x equals 2x minus 75 by algebra, which is the substitution property. So now we're going to be solving our algebraic problem and justifying each step. We have x plus 75 equals 2x by adding the 75 over. So what did we do? We did algebra and we just did addition, the addition property. Finally, if we subtract the x over, then we have 2x minus x, which will give you 1x. So by algebra and the subtraction property, we get x equals 75. And that would be your final answer. And we're done. For these next examples, we just want to name the property of equality or congruence that's going to justify going from the first step to the second step. So you can refer back to your note sheet to figure out which ones they all are, and then just how do you solve these? How would you say, what reasoning would you give for these problems? So for part A, 2x plus 9 equals 19, and then to get to the next step, we have 2x equals 10. Well, what we have done is we have subtracted the 9 over. So, because of that, our justification would be the subtraction property of equality. So we would say that that is the reasoning for this change. The next one, angle O is congruent to angle W, and angle W is congruent to angle L. And then our next step says angle O is congruent to angle L. So what have we done here to go from step 1 to step 2? Well, since they both had the W in them, we said, oh, they're both the same, so we can just say that these two things are also congruent to each other. That's the transitive property. Now, because we are talking about congruence and not an equals, we're going to say it's the transitive property of congruence, but it's really the same idea with equals. And part C, we have measure of angle E equals measure of angle T, and our next step says measure of angle T equals measure of angle E. So all we have done is flip-flopped what side of the equal sign they are on. That does not actually change anything. So this is what we call the symmetric property. And it is the symmetric property of equality because we're talking about equal angle measures. We're not talking about congruence. So that would be your answer for the third one. In this next example, we're going to be writing a 2-column proof. Given that the measure of angle 1 is equal to the measure of angle 3, we want to prove that the measure of AEC is equal to the measure of DEB. So that is our goal. Now, when writing a 2-column proof, what we have to do is look at what we're given and look at our picture and then start there and try to get to what we are trying to prove. So, we're always going to start with what we are given. So, our first statement is measure of angle 1 equals measure of angle 3. Then we have to look at why is that true. Well, that is true because we're told that it is true. Reasoning is given. Okay, for our next step, we have to see where we can go from there. Well, if I look at my picture, I know that the measure of angle 2 is incorporated in both of our answers, in both parts of the answer here. The AEC and the DEB both require our angle 2. So I'm going to somehow work that in there. So that's going to be my next part. So the measure of angle 2 equals the measure of angle 2. Now, why is this true? Well, this is true by our algebra, and it's the same things equal the same thing, and that's what we call the reflexive property. So that makes my reasoning algebra the reflexive property. Okay, so now the next part, we have to use what we have and our picture to see if we can get to something that is equal there with our AEC. So I'm going to look, AEC is right here. So that's 1 and 2. And then we have DEB, which is right here, DEB. So the 2 is part of both parts, and so if we just add them together, then we have something there that we might be able to use. So that would be our next step. So we have the measure of angle 1 plus the measure of angle 2 equals the measure of angle 3 plus the measure of angle 2. And all we did was we added them straight down. What we have done is algebra, or the addition property. Okay, now if I look at the measure of angle 1 plus the measure of angle 2, that is the measure of angle AEC. Okay, and the same thing with the measure of angle 3 plus the measure of angle 2. So what that tells me is the measure of angle 1 plus the measure of angle 2 equals measure of angle AEC. Also, the measure of angle 3 plus the measure of angle 2 is equal to the measure of angle DEB. Since these are the same reasoning, I'm going to put them on the same line. And what is the reasoning? Well, what have we done? We've added two smaller angles to get a bigger angle in both cases. So that would be the angle addition postulate. So because we are adding angles, it's the angle addition postulate. And finally, we should be able to get to where we want to go now. Since we know already that the two parts here are equal to each other, then that means that the equal parts are equal to each other as well. So that's where we can go in our final step, and that should get us to where we want to, what we want to prove. We have the measure of angle AEC equals the measure of angle DEB. Now, the reasoning behind that is like literally we just substituted it in. So it's algebra and it's substitution. Final answer, and just make sure you reason that out by saying it's substitution, and we are done with our proof. Okay, so just go one step at a time. Look at what you are given previously to find out where you need to go next, and your final line should be what you are trying to prove. That's it for your notes over reasoning in algebra and geometry. Summarize your notes. Make sure that you understand what is going on or ask some questions, and then go through some practice problems, and then you might be ready for your quiz over this material.